अभी खत्म हुई रिसेंट, तो वो उसी में अटेंडेंस लगा के
This
सुना
call
रहे हैं।
is now. Okay. Now can you see the screen, all of you? Is it okay? दिख रही है स्क्रीन ये? Am I audible? Laksha, Piyush?
Yes sir.
Yes, sir, you're audible.
Okay, और ये स्क्रीन दिख रही है ये? Can you see the screen?
No sir.
अब दिख रही है स्क्रीन? Can you see the slide? Slide दिख रही है आपको? Syllabus.
Yes, sir.
Yes sir.
Okay, right. So we have almost finished the entire syllabus except the part of Unit 5, which I'm going to start the power amplifier, a bit of power amplifier today. बाकी काफ़ी कुछ हमने ख़त्म कर दिया है, ठीक है? जो चीज़ बच रही है 2-5% you are supposed to cover on your own. 100% coverage cannot be done by the teacher himself, right? So you have to cooperate. And all right, coming back to this textbook or the reference book which we have been talking about since the beginning of this class, right? So I told you that which chapters to focus, for this. So first thing first, ki last semester, learning material on op-amp and related op-amp and all related lectures, right? ये तो बिल्कुल आपको देखना ही देखना है क्योंकि that is part of the syllabus even in this semester. Other than that, things which you need to study from my lecture notes as well as from this book, chapter 4, chapter 5, chapter 6, 7, 8, part of 9, not the entire part. Data converter circuits are not there in the syllabus, right? Then 12, 13, and 14. And this, as I told you. Is that clear now?
Yes, sir.
So please do all this sincerely and meticulously. Solving all the problems given in the book and all the exercises which I did in the classes. Okay, उन सबको करोगे. You have lot of time. अभी भी काफी time है. Date sheet अभी आई नहीं है. आप इन सबको करते रहो. And you can ask your doubts in this week. You still have Monday through Friday time. Saturday, Sunday भी अगर आप कहोगे तो I'll be available. Right? So the syllabus is we are through. What is left is the power amplifiers, output stage, and this part. Okay, so we'll see. how much we can do, right? So before I start the power stage, let me quickly take you to another interesting thing which I somehow didn't deal with. 555 timer IC, we have already made use of this IC for generating the rectangular wave, right? I told you last time that if there are two 555 timer ICs, okay, and both are, let us say, both are arranged in a manner that they are producing six and two, right? So this is connected here. Then you have 7, which comes from the junction of these two resistors, right? Then you have 8 and 4, which obviously goes to plus VCC. 3 is the output. You have 5 पे मैंने कहा है, if it is a stable mode, you will be connecting a very high low value capacitor. Then pin number 1, which goes to ground. That's the stable multivibrator. You have resistor, let us say RA1 and RB1 or small r small a. Okay, let me write it this way. Right, and then you have here the capacitor CA. Okay. Now you have another slight correction. Then you have again 6 and 2. This is connected here. Then you have 7. This goes to junction of the two resistors. This point goes to VCC. In fact, VCC can be made common. So this point can be connected here. You have VCC, this is pin number 4 of this. Then you have 5, then you have 1, 8, and you have 1 goes to ground. Okay. Right. Now this output 3 goes to pin number 4 here. Okay. 5 can have the same capacitor as. So these are the two stable multivibrators. Obviously, the first one, as you can see, first one is without doubt, it is generating some square wave at pin number 3. And let us assume that, okay, here this is, let us say, RA, RB, and CB, right? Second one is also a stable multivibrator, but it is enabled only by the square wave generated at pin number 3 of the first one. जब पहले वाले से स्क्वायर वेव बनेगी, रेक्टेंगुलर वेव बनेगी, जब भी ये हाई होगी, in that only state 2 will generate some 2 का पिन नंबर 3 अगर हम यहाँ निकालें, and if I take this output, this is the output, let us say I am taking. Okay, so one है, one is generating the time axis. Suppose one has one has this kind of right. So T1 and T2 from 1 is given by this. So 1 का जो T1 है ये है, which is actually equal to 0.69 times of yes RA plus RB times CA, and ये एक वाले से है. ऐसे ही this is from the T2 from the 1. इस T2 को आप लिखोगे 0.69 times RB into CA. So obviously, because this output has been given to the pin number 4 of the second stable multivibrator, so only during T1 time, second one will generate the output. So this output is possible only during T1 time, only during T1 time. And let us assume that this R capital A and R capital B and C capital B is such that 0.69 इसको रेड से लिखता हूँ. 0.69 RA plus RB times CB is T1 for the second one. This is T1 for the second one. Similarly, T2 for the second one is 0.69 RB times CB. T2 from the second one. And this T1 from second one is much smaller than T1 from the first one. जो यहाँ पर है, ये T1 first one. Obviously, T2 from second one is also much smaller than T2 from the second one, from the first one, which is this one. Correct? Okay. So with this now, I would like to draw the waveform from this point, the number 3 of the second one. You can see now, अब ये यहाँ पर 0 रहेगा. During T2 of first time, number 3 gives output 0. Whenever output is 0, second one becomes disabled. Whenever 3 of first one is 1, second one is enabled. So here in T2 of the first, during this time, output will be 0. And again, the same thing repeats here. Same thing repeats here. Right? So I hope now you have understood that you are generating the pulse trains, right, during the time when the first or stable multivibrator gives high output. Is that okay? Is that okay?
Yes, sir.
Right. Now let me discuss another important circuit from. So in the stable multivibrator circuit, as we saw just now, what we have been doing, we have been using ये जो दो रेसिस्टर्स हैं RA और RB, इनसे हम इस कैपेसिटर को चार्ज करा रहे थे। सात पर क्या होगा, सात पर आपको अंदर ध्यान होगा, देयर वाज वन ट्रांजिस्टर, एनपीएन ट्रांजिस्टर, ठीक है। और इस पर जो आउटपुट मिलता है वो एसआर फ्लिप फ्लॉप से आता है, ठीक है। और इस तरह से, so now what happens that you have these resistors RA, RB and C, and as you may recall, they this VCC, this is VCC, and it is divided into 3. So you have now 2 VCC by 3 and you have now VCC by 3. और जो कंपैरिजन होता है, कंपैरिजन का लेवल जो है इनिशियली तो यहाँ से शुरू होता है, एक्सपोनेंशियल चार्ज, then exponential discharge, and again exponential charge. So this charge time remains same, and this T1 is, as we calculated, 0.69 times of RA plus RB times C. And then you have T2, which is only governed by the discharge. Discharge happens only through RB. So that is now 0.69 RB times C. And the waveform that is generated is this, right? First cycle error, this is called the first cycle error, which later on is not present. After the first cycle, that error is not there. So you get T1 always same and you get T2 always same. What is important to note that the waveform across capacitor is the green one. ये जो waveform है, this waveform is actually the capacitor voltage with respect to time. तो कैपेसिटर के क्रॉस जो वोल्टेज मिल रही है वो एक्सपोनेंशियल चार्ज, एक्सपोनेंशियल डिस्चार्जिंग की है, ठीक है। सो हियर इफ यू सी दिस VCT, ये जैसा कि हमने वेवफॉर्म बना रखा है, ये एक्सपोनेंशियल चार्ज, एक्सपोनेंशियल डिस्चार्ज इस तरह की है। इज दैट करेक्ट?
यस सर।
और ये जो आउटपुट मिल रहा है ये पिन नंबर 3 से मिल रहा है यहाँ पर। Here the output is this rectangular pulse of T1 on and T2 off, right? Now my question is, I want to generate across capacitor not the exponential wave but sawtooth wave. Sawtooth wave means linear charge and sudden discharge, something like this. I want to generate this kind of pulse. कैसे कर सकते हैं?
Sir, this capacitor is current dependent.
This capacitor is now charging through variable currents. अगर हम कैपेसिटर को कांस्टेंट करंट से चार्ज करा दें,
Yes sir. Sir, तब हम sawtooth wave generate करते हैं.
during this time, if I make sure that capacitor charges with constant current, and then discharge time is 0, T2 is almost 0, right? So you have now a sawtooth generated. तो अब हम ये करते हैं, ये करने के लिए हमें क्या करना होगा? I need to first of all remove these resistors. ठीक है। और इसको कांस्टेंट चार्जिंग के लिए हम अगर if I ये पीएनपी ट्रांजिस्टर लगा दिया हमने, और इस पीएनपी ट्रांजिस्टर को मैंने एक पीएनपी मैच ट्रांजिस्टर से करंट मिरर बना करके now this is, let us say, R1, right? Now what will happen? With this R1, I have ensured that current flowing through this is
Sir, it is dependent on R1.
R1. So that will be actually VCC minus 0.7 divided by R1 is equal to IB, this IB. And this is the IB flowing here. Constant current से चार्जिंग हो रही है इसकी. अब चार्ज होते होते जैसे ही C पर वोल्टेज 2/3 VCC या VCC/3 कंपैरेटर एक्शन आ जाएगा, और जैसे ही कैपेसिटर ये ट्रांजिस्टर Q अंदर का ट्रांजिस्टर जैसे ही ऑन होता है, वैसे ही ये इसके थ्रू डिस्चार्ज होगा, right? So you have charging time is decided by the IB current, right? And discharge time will be relatively very small. It will be very small, charge and discharge. Correct? So sawtooth will be generated across the capacitor. Is that correct?
Yes, sir.
Okay. Now you can figure out what will be the charging and discharging time period. It is left to your आप इसको घर पे करके then you find out what will be the T1 and T2. Right, let us now move ahead with the, okay, moving ahead with the power amplifiers. You need to go to the chapter 14 is the output stages and power amplifiers, correct? So what happens in an amplifier? Let me in any amplifier, there are various stages, okay? Let us imagine that's the complete amplifier, okay? And here we have the input, here we have the output. That's where we connect the load, okay? And it is very important to note that this amplifier is biased with supply, the plus VCC and minus VCC, correct? For instance, you may assume that at the output we have connected, let's say, speaker, which is the load. At the input we have connected the microphone, which is the source, the signal source. Is it okay? A typical situation of the application situation of an amplifier. Is that okay?
Yes, sir.
Now, if I ask you, if I don't give any signal from the microphone से कोई भी signal नहीं जा रहा इसके input में. There is no signal going here. What you will be noticing at the output? Will there be any signal current flowing through the speaker when there is no signal given? अगर ये input नहीं है यहाँ पर, will there be anything audible in the speaker? Will there be any current flowing through the speaker? Answer is no. Nahi? Because we are not giving any signal, therefore there will be no signal flowing through the speaker. Is that okay?
Yes, sir.
Okay. Now in this situation, tell me, will there not be a current flowing through the power supply? तो इसमें अंदर बहुत सारे ट्रांजिस्टर्स लगे हुए हैं, हो सकता है कुछ पीएनपी ट्रांजिस्टर्स हों, राइट, हो सकता है कुछ एनपीएन ट्रांजिस्टर्स हों, और इनको बायस करने के लिए बहुत सारे रेजिस्टर्स लगे होंगे, बहुत सारे बीच में कपलिंग कैपेसिटर्स होंगे. You don't know their connection arrangement, we don't know, but they're all connected. They are all connected between plus VCC and minus VCC, and they're all and then connected to the input and the output. The only difference कि input से कोई current नहीं flow कर रही, output पे कोई current नहीं जा रहा, but they are still connected to the plus VCC and minus VCC. So we expect some current which flows through this, right? Is that okay? Is that okay? That current is actually required to provide bias to these different stages. इसमें इस एम्पलीफायर में बहुत सारे स्टेजेस होंगे, उनको बायस देने के लिए इन करंट्स की जरूरत है, right? So you may now think of this amplifier having various sections. The input stage, you may call this input stage, and you may think of another stage of amplifier which is called the gain stage, जहाँ की सारा gain बढ़ जाएगा. Then you have the driver stage which drives the power amplifier, and then you have the power stage, power amplifier or power stage, and then finally it goes to the output. एक एम्पलीफायर में नॉर्मली इस तरह का अरेंजमेंट होता है. You have the input stage which ensures that the input of the amplifier is properly matched with the source that we have at the input, so that without loading unnecessarily the source, it takes in all the signals and then passes it on to the other stages of the amplifier for the amplification purpose, right? Likewise, at the output stage, you have the power amplifier stage. What it does, it ensures that the output of the amplifier is well matched with the load that we are intending to connect there. Normally loads क्या resistance जो होता है RL is very very small. आपको अगर एक example दूं, RL for speakers जो बाजार में मिलते हैं वो 4 ओम, 8 ओम, 12 ओम, 16 ओम इस तरह के रेसिस्टेंस के मिलते हैं. मतलब स्पीकर का इम्पीडेंस 4 ओम, 8 ओम इस तरह की रेंज का होता है, which is very low. And therefore, in order to deliver power, the entire power of the amplifier to such loads, इसे heavy load बोलते हैं. जब भी RL की वैल्यू कम होती है उसे heavy load बोलते हैं. Please note, heavy load does not mean RL is higher in magnitude. Heavy load means it draws more current, right? So when the RL is small, it will draw more current. So जो output stage है power amplifier या the output stage is also called output stage. Output stage should be capable of handling or delivering all the power to the heavy load, right? Therefore, अगर यहाँ पर आउटपुट इस स्टेज का हम इक्विवेलेंट सर्किट बनाएं तो क्या होना चाहिए? एक ऐसा डिपेंडेंट वोल्टेज सोर्स हो जिसका कि आउटपुट इम्पीडेंस RO it should be much smaller than the RL. Now you can understand what I'm trying to highlight. अगर ये 4, 8, 12, 16 ओम का है तो इसका जो इंटरनल इम्पीड जो आउटपुट इसका जो आउटपुट रेसिस्टेंस है इससे भी कम होना चाहिए. You follow the point? और ये जो एम्पलीफाइड सिग्नल है then it should be it can be given to the load. Is that okay? Is that okay? Is that all right? Abhinav Kumar, can you repeat what I said just now? Aditya Anand? Aditya Aryan Verma?
Yes, sir.
Can you repeat what I just now described? Akshat Dwivedi, are you there? Ajay Bansal? Deep Pal? That's really unfortunate. So I'm stopping the class today. I cannot teach like this. I mean, if you people are not listening, there is no point talking to the wall. It doesn't make sense. Please mark your attendance and sign off. Do it fast. Please mark your attendance, all of you. And please leave the class now. Please mark your attendance and leave the class.